Hello, ma'am. Good morning to one all. This is Kenishit. I am from ECB section. My roll number is 219518044. Today's my topic is incremental clustering with table of contents. Why clustering? Why incremental clustering? Related work incremental CTM, a former implementation of C21CM for very large data sets. Conclusion. Why clustering? It is an effective tool to manage information overload, to browse large document collections quickly, to easily grasp the distinct topics and subtopics concept hierarchies, to allow search engines to efficiently query large document collections. Types of clustering: hierarchically versus non-hierarchically, partitional and agglomerative, deterministic or probabilistic algorithms, incremental and batch algorithms. Why incremental clustering? The current information explosion, popular sources of informational text documents such as newswire and blogs, delay would be unexpected in several important areas. Related work: the cluster splitting approach, adaptive clustering based on queries, cobweb algorithm, hierarchical clustering in incremental manner, C2ICM algorithm. C3M is known as an efficient, effective, and robust algorithm for clustering documents. C3M is well developed for initial clustering, but maintenance is also necessary in clustering. C21CM algorithm is based on cover coefficient concept as C3M. C21CM is suitable for dynamic environments where there are additions and deletions of documents. With C21CM, reclustering for each update is avoided. First, C21CM algorithm details. First, we compute the number of clusters and cluster speed powers in the updated database. Then we determine the newly added documents and classified documents. How does clusters become false? When a seed document becomes non-seed or is deleted, one or more non-seed documents of that cluster become seed. We cluster these documents by assigning them to the cluster of seed that covers the most. The documents which does not belong to any cluster are grouped into ragbag cluster. CCM an example. Current state of the cluster. In one cluster, D1, D2, D3, D4, and D5, D7 are there. And the second cluster has D6, D7, D8, D9, D10. And the third cluster has the D12 to D18. And the fourth cluster has the only one D19. And the fourth cluster is known as the rag black cluster. Seed list D1, D6, D12. And this is known as the cluster names. When the seed when a seed document becomes non-seed, D1, D2, D3, and the fourth seed, the set of documents to be clustered. D19, D20, D21, D22, new documents arrive. The old seed list is D1, D2, D12, and the new seed list is D1, D6, D13, and D19. Seed document D12 becomes non-seed. So the third cluster and the fourth cluster combined and become the one cluster, and the fourth cluster contains the 13, 14, 15, 16, 17, 18, 19, 20, 21. The new seed list is D1, D6, D13 and 19. That's why the cluster contains the two seed lists. Final cluster becomes D1, D2, D3, D4, D6 to D10 and D13 to D20, and the D19 comes here, D17 comes here. Some of the clusters of middle D18 to D19 came this year. No elements remaining in the cluster ragback cluster. The new seed list is D1, D6, D13 and D19. In case 2, when a non-seed document in a cluster becomes non-seed, and that the new comes the set of documents to be clustered in a fourth cluster is D19, D19, 20, 21, 22, and the new seed list is D1, D6, D12, and D14. Non-seed document D14 becomes seed, so that the D14 becomes new seed, then the D14 and D12 are the new seed list. Cluster adds the fourth cluster and third cluster. Final cluster is D1, D2, D3, D4, D5. D6 changes to second cluster and the D7 remains in the first cluster. Since the second cluster contains D6, D7. D7 comes to the cluster, so the D8, D9, D10, D11 and the D14, 15, 16, 14, D11, 12, 13, 14 comes to the third cluster and the D15 remains in the second cluster, and the third cluster contains of seeds D12, 13 and 15 in the second cluster, 14 in the fourth cluster, 16, 17, 18, 19 in the fourth cluster, and D20 is that. After the fourth cluster becomes new seed, D14 is the list name. So the D14, D19, D21 and D17 in the fourth cluster. No elements remaining in the cluster rack. A former implementation of C21CM for every large datasets. C21CM is implemented by two programs versus Pascal. Program 1 selects the seeds. Program 2 cluster documents by using C2M algorithm. These programs communicate by exchanging files, documents, seed selector, text files, program to C21CM clusters. Former experiments. C21CM is tested with a subset of Marian database 43K documents in 1995. 6 experiments are done. Each experimental update added 6K documents to the different sizes of initial cluster documents. Results for the former experiment. C21 provides time saving. Cluster formed with C21CM was very similar to the cluster formed with C3M. Increments and execution time from 0, 13.551, total savings, etc. The calculation of the table is exceed. The conclusion. The cluster maintenance problem is challenging. Our aim is to conduct experiments for C21CM with very large number of documents, that is millions of documents. Hard database will be used for evaluation information. Retrieval performance will be measured. Implementation of C21CM must be time of the memory efficiency. Reference. By reference, can F. Osaka EA concept and effectiveness of the cover coefficient database clustering methodology of text database ACM transactions on database systems number 4 on December 1990, and can incremental clustering of dynamic information processing Savely France Arca incremental clustering of very large document database initial Marian information science in 84 volume 84 in 1955. A.K. Jain, M.N. Murthy and P.J. Flynn Data clustering, a review, ACM computing survey, CSUR, volume 13, number 3, page number 256, 35, September 1996. Thank you for giving this wonderful opportunity.